Here we have an example with an external cost resulting from pollution. Notice again that the external cost here is $2 per unit, giving us a constant marginal external cost, which greatly simplifies the math in this problem. So we'll begin by finding the market equilibrium. Here, where supply intersects demand. So I've got 9 plus 0.3Q is equal to 1 plus 0.5Q. So 0.8Q is equal to 8, and the market equilibrium quantity is 10. Price will be 6 at the market equilibrium. Now we want to compare that to the socially optimal outcome, and we know because we have an external cost that the market will produce too much of this product. We'll find the marginal social cost curve by adding together our private cost described by the supply equation with the marginal external cost. That gives us 3 plus 0.5Q. And our socially optimal point then will be here. We can find that quantity by setting our marginal social cost curve equal to the demand curve, which represents our marginal social benefit. And we get 6 is equal to 0.8Q. So our socially optimal quantity is 7.5. Again, you can see the market here has produced too much of this product because it's failed to take into account the full cost in terms of pollution. That results in a smaller amount of total surplus at the market equilibrium than at the socially optimal point. So if I think about surplus at the market equilibrium, we'll have consumer and producer surplus, which again is maximized at the market equilibrium because that's where our private benefit to our consumers and producers is highest. But what we fail to take into account is the additional external cost, which could be represented by the area between our marginal social cost and our supply curve. And once we take that into account, we can see that our deadweight loss triangle results from the fact that as we expand production beyond the socially optimal quantity, the cost of production is higher than the benefit. That's not good, right? We don't want to do things if the cost is higher than the benefit. And that's where our deadweight loss comes from in this example. So I can calculate the area of this deadweight loss triangle. It's 1/2 times the height is the marginal external cost, which is 2 in this example, right? That's always just going to be given in the problem. And the width of the triangle is the difference in the quantities. So that's going to be a total deadweight loss of $2.50. What that tells me is that my total surplus, the total benefit to all groups within society, is $2.50 higher at the socially optimal quantity, which is 7.5, than at the market equilibrium, which is